Hello everyone, welcome to Radco Academy, and in this video we are going to look at organic chemistry. Now most of us, we have a challenge when it comes to organic chemistry, not because we should have a challenge, but some people have just a negative perception about chemistry, because probably some of us, we never had a chance to understand what a periodic table is all about. Now, nevertheless, we're going to actually make this simple to our learners, and this is about organic chemistry. And because many people find it so, annoying, there's a lot of, the naming and all that stuff, trying to understand what is going to be the reaction, what is the name of this compound, and all that kind of stuff. But in this video, we're going to actually simplify a lot of stuff. So if you're new to my channel, remember to subscribe, like, as well as share this video so that you never miss my content. So let's dive into this. So when you look at organic chemistry, okay, we are talking about something that is natural, okay. Now, most of the time when you talk about organic, okay, the word organic is attached to the word natural stuff, okay. And normally, there is a plenty of things that we know, or many people want things that are natural, okay? But again, we have to understand what makes things natural, okay? What makes things natural? What exactly kind of elements or atoms that forms things that we call organic or natural stuff? Now, one of the things, so we are trying to understand the natural chemistry of the world. So the natural chemistry of the world. So organic chemistry actually deals with compounds. So compounds such as carbon, a bit of sulfur, oxygen, and hydrogen. Okay. Now, this is not to say that these are the only compounds that forms the natural things of that we see or that we understand. Now, about this compound that I've just suggested, okay, we have carbon, sulfur, oxygen, and hydrogen, as well as also nitrogen. The most important thing to understand, ladies and gentlemen, is that amongst all these elements, okay, there must be one that is very important, that is very significant when it comes to the nature of something, the natural things, okay. And this thing is about carbon. Now, we have to understand, and the question should be, why carbon, okay? So now, because carbon, when you look at the periodic table, the basics of the periodic table, we are saying that carbon, okay, has got 6 protons, and yeah, so we have this form of carbon, that is carbon 12, and the proton numbers are 6, okay. Now, from this, when you do an electronic configuration, when we do configure the carbon, is at this 6, you have 2, 4, okay? Now, what is the implication of this is that the last number, so the numbers are in the last shell, okay, of that carbon atom, okay? What we're just simply saying is that carbon has a capability to form or to be attached with 4 atoms at maximum, okay? So this gives us, this actually gives carbon the power, okay, at least to be able to form different kind of compounds. And those different kind of compounds, the backbone is actually carbon, okay. So now, because of that, then the carbon is the most important thing when it comes to organic chemistry, okay. So, what are we saying? So when you're learning about organic chemistry, okay, when you're learning about a lot of organic chemistry, okay, we have to understand what is called hydro. We have to understand that having understood what carbon is able to do, and now we can begin to be able to understand things like segmenting things like hydrocarbons. Okay, so the hydrogen, the combination of hydrogen as well as carbon together forms compounds that we call hydrocarbons. Okay, so these they contain So now they contain carbon and hydrogen. So now these hydrocarbons, they can be classified. So the hydrocarbons can now be classified as we have what is called the alkanes. Now, when you look at these three classes of hydrocarbons, again, when you look at these three classes of hydrocarbons, we are saying that we have the alkanes, the alkenes, as well as the alkynes. Okay. So now you have to understand what we mean by classification. Okay. Because once you understand that we have these three kinds of classes that forms what is called hydrocarbons. Okay. So compound that contains hydrogen as well as carbon. So these are the three of them. Now, once you understand these, okay, organic chemistry becomes very simple and something that is easy and straightforward, because I'll be able to see if a compound that I'm given belongs to this class or the family, such as the alkanes or even just the alkenes or even the alkynes. Okay. But also, after this, we're going to actually also look at what is called the derived hydrocarbons or derivatives of the hydrocarbons. Okay, so there are those hydrocarbons that do not just contain the hydrogen as well as the carbon. So there are those that consist, maybe some of them will start now consisting of oxygen. Okay, so they are not primarily or rather the fundamental hydrocarbons, because the hydrocarbons, they contain hydrogen as well as carbon. So after understanding that, then we will be able to look at those things again. Now, having said that, we can now go into the idea of what is an alkane. So this is a class of the hydrocarbons again, and this can be defined as hydrocarbons compound that have a single carbon to carbon Okay, so the alkanes are just hydrocarbons that have single bond between the carbon to carbon bonds. So I'm going to actually show you what that implies or what that means. Okay, so from there, one of the easiest example, okay, so I'm just going to assume that I'm giving you an example. So when you look at one of the example of the alkanes is that methane. Okay. So we have the methane. So don't worry about where the name has actually come from. I'll be able to share with you as we move along, where you can be able to get all these names that, like for example, the one that I've mentioned. Okay. So when you look at this one, the methane, it is just a compound, okay, that has got one carbon and surrounded by 4 hydrogen. 4 hydrogen atoms. Now, one of the important things that I want you to understand is that this is a structure of methane. And basically, if you understand the structure, okay, so for me to come up with the structure, I also need to have also the molecular formula of this structure. Now, the molecular formula is actually derived from what is called the general molecular formula under the class called the alkanes. Okay, so now the alkanes, they have this CN H2N plus 2. Okay, so this is what you call the general molecular formula of the class of hydrocarbon called the alkanes. Okay, and for you, what this means is that you can only use this formula to actually generate a molecular formula for individual compounds that falls under the alkanes, and from each of the molecular formula for the individual compounds, we can now be able to draw the structures of each of those hydrocarbons within the alkane class. Okay, so from there, I'm going to actually show you. Okay, so now, so having looked at the alkanes, I want you to understand how can you generate the molecular formula for a specific compound. Okay, and then also probably draw its structural formula, just like you saw just in a minute ago about the methane. Okay, so I'm gonna actually do 3 of them, and then from there we'll keep on going just step by step. Okay, so I said we had methane. Okay, and then we know that this is a general molecular formula. Okay. Now, what you do is that we have within the alkanes, we have methane, we also have ethane and propane. Okay. So, based on example, just gonna look at 3 of these compounds within the alkanes. Okay, so what you have to understand that under the alkanes, which are single bonds between the carbon to carbon atoms. Okay, and yeah, so we have this is a general molecular formula, and this is the first one. Okay, and this is the second one, and this is the third one. So the most important thing to understand is that these names are actually derived based on the position within the numbering system. Okay, so the first one is meth, or rather the word, should I say, the prefix meth means 1, eth means 2, prop means 3. So whenever I change from the alkanes, I go to something else, that will still remain constant, okay, the numbering system. Okay, but for any information that you have to understand is that methane is on number 1, ethane is on number 2, propane is on number 3, and then just like that, butane, decane, just like that, okay, up to the 10. So if you are writing your final exam, the most important thing that you have to know is from 1 to 10, okay, those are the things that you have to know. So now, if I want to get the general formula for propane, then what I'm going to do, So what I'm going to do is, because propane is on number 3, so in the formula, the N is actually representing the number of carbon. Okay. Okay. So the N represents the number of carbon in the formula. So if a compound is on position number 3, it simply means that in that compound we have 3 carbon. If it is on number 2, in that compound you have 2 carbon. Just like that, 1 carbon. Okay. So if I do all the 3 of them, so for methane, so number 1, so to come up with the general formula, the molecular formula for methane, we have to say N equals to 1, and because of that, then you say C, you just put 1 there, 1, H, 2, open bracket 1 plus 2. So when you look at what I've done, this is just a simple mathematical replacement, as in like a mathematical expression. Okay, so this means 2 times 1. Okay, so because if N is 1, there is no need to show the 1 underneath the carbon. So you just say C, and then this is 2 times 1 is this 2, plus this 2, it is 4. So we have 4 there. Okay. Now, from here now, we can actually draw the structural formula. So the carbon should be at the center and surrounded by 4 hydrogen. So it is surrounded by 4 hydrogen. Then we can say now, I want you to understand that the most important thing again is that you have to ensure that the carbon is actually attached to 4 strings of, it is able to form 4 bonds that other atoms can come and join to that, okay? Otherwise, if you have more than 4 bonds formed from the single carbon, okay, then that's going to be a problem, okay? And then we got to this. This is ethane, okay? So on number 2, so our N equals to 2, okay? And this is going to be C. From the formula, it is this C2H open bracket H2 open bracket 2 plus 2, okay? And when you do, because C has 2 there, so you keep this one. This 2 times 2 is 4 plus 2, that is 6. Now, the structural formula is going to be, now because we have 2 carbons now in ethane, okay? So this implies that between the carbon to carbon, okay, we are going to have 1 bond, okay? So we have this, okay, and another carbon. So now this is what you have, okay? This is what you have. So 2 carbon, and between the carbon to carbon, okay, there is only 1 string of the bond, okay? A single bond, by the way, okay? And when you count the number of carbon, okay, that are attached to these, they must be able to count to 6. So 1, 2, 3, 4, 5, 6. So we have 6 carbon as the formula says that, okay? Now the last one is going to be propane. So propane is on position, on numbering system, that is position number 3, okay? Okay, so now we're going to actually go to propane. Okay, so what's going to happen now? So the formula is CnH2n plus 2. Okay, now because it is on number 3, so our N is just 3, or that means the number of carbon. So replace C3H2 3 plus 2. So from there, what you have is 3. This 2 times 3 is 6 plus 2, that is 8. So now, this tells you that you have, this now tells you to say you have 3 carbon. So a compound with 3 carbon, that is propane, and it has got 8 carbon, okay, surrounded to that. So this implies that this propane, this is the molecular formula, okay. So now we have to come up with the structural formula based on the molecular formula. So we have to draw horizontally, okay. 3 carbon, okay. So these 3 carbon, and then we attach 8 hydrogen atoms. Okay. So now you can see what you have for propane in terms of the structural formula. Okay. So as N increases, okay, so is the number of hydrogen increasing. Okay. So when you look at this, you have to be able to confirm if the number of hydrogen are just correct. 1, 2, 3, 4, 5, 6, 7, 8. So if you have more than 8 atoms of hydrogen involved in the structure, or even just in the structure. So if you have more than, then you have a problem in the way that you are indicating the number of hydrogen atoms. So this is about the alkanes, okay, the first class of hydrocarbons. Okay, so thank you so much. I'll see you in the next video. About now we're going to advance now, looking at maybe some of the reaction, maybe properties of the alkanes, and maybe other things under the alkane. So remember to subscribe, like, as well as share my video. Thank you so much for watching, ladies and gentlemen. This is Radical Academy, and it's bye-bye.